As you would have seen in the previous videos in the previous parts of the lessons, we can say that all measurements are made in some frame of reference. And as you can see in the videos, and as I'll talk about in just a couple minutes here, when we see things moving or consider things that are going back and forth, this idea of frames of reference is usually pretty clear. So for instance, let's suppose you're on a train and the train's going 90 kilometers an hour and a person runs by you towards the front of the train at 15 kilometers per hour. So what is the person's speed with respect to you? So WRT, respect to you. You would say they're going 15 kilometers an hour. However, let's suppose your friend was on the outside the train, standing beside the train tracks, watching the train go by. If they could see inside the train, what would they see? Well, they would see the train moving 90 kilometers per hour, and then they'd see the person running forwards a little bit faster, another 15. They would see the person running 105 kilometers per hour. So that's 90 plus another 15. And we can think of that in terms of adding up two vectors. So this is the train with respect to the ground. This is the person with respect to the train. And when we add those two things up, so this is like the 90, this is the 15, so 15, 90. They'd add up to, well, it's not a very straight line, but they'd add up to a resultant vector that is 105 kilometers per hour. So that's the idea of adding two vectors that are in the same line in terms of frame of reference. It gets a little bit trickier when we think about things that aren't going in line, but maybe with a little bit of thinking about it, we can sort things out. So let's suppose that you're lying on the ground, you look up and you see a bird flying north, let's say 10 kilometers per hour. And then the very next day, you see you look up, you see the same bird flying the same speed, but this time there's a wind that's blowing 5 kilometers per hour that way. So what would you actually see? So the wind's not pushing you, but the wind would be pushing the bird. And what you'd see when with that bird flying above you is, it'd be going this way 10, and this way 5. So in fact what you'd see is the bird going like this. And you'd see that bird's velocity as, well, v would be, you could use Pythagoras. So v squared equals 5 squared plus 10 squared. So v equals 125 square root 11.2 meters per second. And you can find out that angle as well. That is inverse tan of 5 over 10. It's a half, 0.5. So that's 27 degrees. I kind of skipped through, let's just take a, go through that a little bit slower. Tan theta is opposite over adjacent. So there's our theta, this is the opposite, this is the adjacent. That's where that comes from. And then when we want to solve for the theta, we take the inverse of it. So this is an example of how you could add up relative velocities using trigonometry. In the next part of this lesson, I'm going to have you go to a web page, and that web page is going to have it's called the Riverboat Simulator. So you're going to click on, I'll give you that URL. You're going to click on Launch Interactive, and then you can click on, you can make it bigger this way. So I suggest making it big. And what this Interactive allows you to do, this is a boat going across a river, and you can adjust the speed of the river, and you can adjust the direction of the speed of the boat, and you can also adjust the direction the boat's heading. So if this was, if the river's not, I don't know if you can go to 0. Yeah, we always, so let's say the river is moving 6 meters per second, the boat's going 10 meters per second. The boat's going to aim to go straight across. So this would be, imagine if you're trying to swim across the river and you point straight across the river, what happens? Press play. You don't get across straight. You end up going downstream a bit. So you can reset that. If you want to go upstream, or if you want to go straight across, you kind of have to somehow point upstream a little bit. Something like that. Maybe a little bit more. Let's try that. There you go. So the next activity, you're going to play with this simulator a little bit.